Hello everyone, in this experiment we are going to explain the phenomena of diffraction, which is basically bending of light around obstacle which are of the order of its wavelength. We have characterized diffraction by a open source software MEEP by using finite difference time domain method by placing a continuous wave point source. So this is your first case where obstacle size is much smaller than the wavelength, and you can see how the wave bend around the corners of the obstacle. So this is diffraction for you. So this is second case where we have increased the obstacle size, but it is still less than the wavelength of light. So again you can see diffraction and the bending of wave around the corners of the obstacle. So what happens now if we increase the obstacle size to wavelength? You can see that there is diffraction, but it is not quite as prominent as first and second case, but still there is bending of light around the corners of the obstacle. Now if you go on to further increase the size of the obstacle, say 6 units, you can see that there is no diffraction, a very little. You can see that just little bit of wave bending around the corner, but there is no prominent diffraction. And if you still continue to increase the size of obstacle, say 10 units, so now what will we observe? We observe that there is no diffraction, no bending of light around the obstacle. So as we increase the size of obstacle greater than the wavelength, there is no diffraction. These are the parameters we have used, including lattice size and our resolution. And this is the source code which we source MEEP code which we use to render our results. And this is all about PML layers and resolution and how to generate images and GIF files. And special thanks to our teaching assistant Saik Bhattacharya.